All right, let's look at the cosine rule. Cosine rule, you're given a triangle and you're labeling it with capital A, B, C, let's say, on the vertices again. B over here, opposite B, and C, opposite C, and small a, opposite A as well. So here we're going to use cosine rule. Okay, so in order to calculate the length of A, which is A squared, let's say, in this case, the formula will start from this. Okay, so let's say I want to go with finding the length of A. The formula is A squared equals B squared plus C squared minus 2BC cos of angle A. What you notice about this, if I want to find this side, I need this side, I need this side, and I also need the angle in between, which is A. You notice B is repeated twice in the formula. So I need this side, the angle in between, and that would give me this opposite side there. Okay. I can also rewrite this formula in another way, where let's say I want to find this length, C. So if C squared is what I'm trying to find, then I'm going to end up with A squared plus B squared minus 2AB cos angle C. And what you notice every time, the side and the angle matches up. The side and the angle matches up in the formula. So C will match up with angle C. And then B squared equals A squared plus C squared minus 2AC cos angle B. So they'll be matching up over there as well. Now using each of these, I can rearrange the formula to make the angle the subject. So let's suppose I did that for this one. Let's say I make angle A the subject because I want to find angle A using all the other sides. If I make angle A the subject, I'm going to get A squared minus B squared minus C squared equals negative 2BC cos angle A. And then from here, I can multiply by negative throughout. So negative A squared plus B squared plus C squared equals 2BC cos angle A. And I can move this around, so this will become B squared minus A squared plus C squared, so it looks nicer, and divided by 2BC, and then move cos over completely, getting me angle A. And that could be seen as another formula. Or you could substitute it into this formula and then do all of these steps anyway, instead of memorizing that. Either way, if you remember just one formula or how to use one formula, you can adapt it all the way through. Okay. For each of these, remember you have, for these three over here, you have two sides and the angle in between. And you can work out the other side. Two sides, the angle in between, and you work out this side. Two sides, the angle in between, and you work out this side. Now, on the same token, if you have all the sides, you can work out any angle using this formula. Generally, these formulas are given in a formula sheet. You can just double check with that. Let's have a look at an example now where we're calculating sides using the cosine rule. And then we'll have a look at one where we're calculating angles. Okay, so over here, I'm given A, B, C. Now, they might not label these for you. So let's suppose you're not even given it as in a labeled form. So let's say they tell you that this length is X, and they tell you that this angle is 45 degrees. This length over here is 21 meters, and this one looks less, let's say 18 meters. And they want you to find length X. So you got to look at it and say, okay, well, do I have enough information? Can I label it, etc.? Let's see what happens, right? So I'm going to start from here, and I'm going to make this, let's say I call this angle A, which means I will call this A. I can choose to call this B or that B, that's up to me. I'm going to call it C, which means that becomes C and that becomes B. And because I want to find A, I'm going to use the formula A squared equals B squared plus C squared minus 2BC cos angle A. And now it's all about substituting very carefully in, not much other than that. So I've got x squared equals b squared, which will be 21 squared, plus c squared, which would be 18 squared, minus 2 times 21 times 18, cos 45 degrees. Putting this on the calculator, so I got 21 squared plus 18 squared minus 2 times 21 times 18 cos 45 comes to 1,299.57. And then square rooting both sides. So square rooting this answer comes to 36.05. And that's going to be the length in meters. So x is equal to 36.05 meters. Done. Now, if I want to find a missing angle using the cosine rule, all right, let's say I want to find one of the other angles. Okay, suppose this angle over here is theta, and I'm asked to find theta. So in order to find theta now, I know that forms part of angle C. And because that's part of angle C, I can use the formula rearranged, but I need to have C over here in the formula, which means I have to have C in this part. I have to have C squared equals A squared plus B squared minus 2AB, angle C, cosed. Do I have all the side lengths? Yes, I do, which means I can substitute into all of those and find C. Instead of rearranging this equation, I'm just going to substitute it into this exact same equation and then solve for C, angle C. So C, which is small c in this case, is 18. So that's going to be 18 squared equals A, which is going to be 36.04 squared, plus B, which is 21 squared, minus 2 times 36.04 multiplied by 21, cos angle C, and I can now simplify each and every part of this. Okay, so what is 18 squared? Let's start from the 18 squared. Gets me 324. And then 36.04 squared comes to 1,298.88 plus 21 squared is 441 minus 2 times 36.04 times 21 cos angle C, we just write there again. So 2 times 36.04 times 21 is actually 1,513.68 cos angle C. And now I'm going to subtract everything over the other side. So 324 minus 1,298.88 minus 441 comes to negative 1,415.88, which is equal to negative 1,513.68 cos angle C. The biggest problem over here is making any silly errors. Okay, so dividing both sides by that negative 1,513.68 gets me negative 0.93, no, positive 0.93538 9 equals cos angle C. And so angle C, once I move cos over and shift it, gets me 20.7 degrees. 20.7 degrees for angle C. And if I'm asked to find angle B, we know that's going to be 180 degrees minus 45 minus 20.7, which is 114, which is an obtuse angle. And therefore, our diagram is actually not drawn to scale, and I can redraw it. So let's say we asked whether the diagram is actually true or false. That could be a question. Then we could say this diagram is false because it does not display the obtuse angle of B. And that is actually how it should look, more or less. This is more or less how it should look. That is where B should be. This is where A should be. And this is where C should be as well for this.